Okay. Okay, it's time for the next presentation. It's called Demystifying Event-Related Software Concepts and Methodologies. Please welcome Milen Dyankov.
Thank you. Hello. All right. Is it working? Can you hear me? All right, great. Thank you. Sorry for the technical issues. I've been in software engineering for like close to 30 years now. I have zero understanding of why this thing didn't work here. But anyways, we have a little delay. I'll try not to rush too much, but I'll still try to figure out a way to squeeze the presentation into the time that we have, not to eat up your lunch break. So as introduced, my name is Milen Dyankov. I work for a company called AxonIQ. And AxonIQ is focused on helping software developers and engineers deal with event-driven systems, surprise, surprise. My role is a developer advocate, which basically means I meet a lot of developers out there who are building event-driven systems and try to kind of bridge the gap between what's the thing that we offer, how we can help, and whatnot. And as such, we have a lot of conversations about event-driven. Event this, event that, and we kind of use the word event in pretty much every single case. And once you do it very often, for a long period of time, one thing you start to realize is that people tend to use the same words over and over again, and they mean completely different things by that. And then it's like sometimes it's super hard to figure out why these two people cannot understand each other, because they seem to be using the same word, the same language, but what they have in mind is actually completely different things. And so this is how this talk emerged. It's like, okay, let's put some understanding behind those terms that we keep using, and those words and those methodologies and concepts and whatnot, so that we can actually have a common understanding of the things we're talking about. So I hope you don't mind joining me for a little journey through the event land. And as with every journey, we'll start that at the door. So here is the door. And there are two things you know about that door. You know it has an ID. It's 28. And it has a color. And it's yellow. Wait, it's not yellow. Yeah, it's red. What just happened here? Well, you just observed a change. But if you have a system that only stores state, picture a database, for example, or anything else you use to store state, the record says ID 28, color, property column, whatever it is, red. And it's probably OK unless you want to answer these questions. Why it is red? When it became red. I mean, you observe the change, but if someone is just entering the room right now, for them, the door is red, never been anything else, right? And then who made that change, and for what reason? And what was the color before? So if you only have a record that says ID, color red, you can't answer any of those questions. But what you can do is, instead of storing state, you can store the change. You can basically store something somewhere like Joe painted door 28 red yesterday. Now, if you have an efficient way of doing this, answering those questions is relatively simple. You know it was painted, that's why it is red. You know it happened yesterday, you know Joe did it, right? And then the only tricky question becomes, what was the color before? That is not to be answered immediately by just that statement. But if that is how your storage works in general, if you store changes, aka events, right, then you can look back in your history and you can see all the events related to door number 28 and scroll back up until the event that says yellow door number 28 was installed. And so since there are no other events between those two, you can safely deduct that the previous color of the door was yellow. So if you switch your mind from saving the current state to saving the changes, or so-called events, that led to the state, there's a lot more things you could do with systems. Now, I mentioned the word event many times, and let's have a little definition of what we mean by event. So event essentially is a tiny piece of information that notifies someone that something has happened. Now, the important part to notice here is the past tense. It has happened, period. It cannot unhappen, right? It's done deal. Why is that important? Because it is the essential reason, whether you realize it or not, why most people use events. They're immutable. And as developers, we love immutable things, don't we? Okay. So we do, by the way. So yeah, we like immutable things because there's a lot less to worry about. And events are this. They're immutable things. They happen. That's it. Deal with it. I mean, so you cannot undo an event, but what you can do is you can perform what's called a compensating action. So you can do something else that restores the state as it was before this event occurred. But that is going to trigger another immutable event. So in that sense, you have the full history of everything that happened. I paid the money to the wrong person. Oh, I withdraw the money back, right? It's not like we never sent money to anyone. We never made a mistake, right? The record of making a mistake is there. The record of fixing the mistake is there. It's all immutable. It happened and it's stored. And it doesn't change your state as of today, but it shows exactly what happened in the system. Or Martin Fowler puts it this way: if you store that, if you think in events and store events, you make a change, a first-class thingamajig in your system. You now have a way to represent a change in the software system. Not a state. We all know how to deal with state. I mean, we've been dealing with state for a very long time, but now we have a conceptually new thing. We have the ability to store changes. It was like this, and now it's like this, and this because of that, right? So if you want to model system that is based on events and storing changes, how do you do that? There's several ways to do that. One of them is called event storming. How many of you familiar with event storming? Few hands I can see. So event storming is a business process discovery and design technique. And it was introduced by this guy, Alberto Brandolini, circa 2013. And so the goal of event storming is to build a shared understanding of the system within every single person involved with that system. And every single person does not mean every single developer, means literally every single person. So if you're building systems for financial or telco or whatever else, you also want to get your domain experts involved in that, the people that understand the business and not necessarily your lines of code, right? They also need to understand how that system works. They also need to be able to provide you feedback that you understand, right? So unless you have a shared understanding of that system, it's going to be very hard. So this is what event storming aims to do. And it basically does this on a giant board with sticky notes. And it starts with the events. So you basically say, what are the things that can happen in this system? This thing can happen. Like this may change, this may be added, this may be removed, whatever, right? And then you start reason about those things. Like, okay, if this can happen, like why it happens, like what causes it to happen? And when it happens, who else needs to react to that? And when you have all these people in the room, all of a sudden you start discovering things like this can happen. And then guys from the other departments like, oops, we never knew it could happen, right? And we never took, account that, right? So that is the idea of event storming. You get these people to understand the things that can happen and how to handle them, how to deal with them. Another approach to model systems this way is so-called event modeling. Now, event modeling is a little bit newer, and it's branded as a blueprint for a solution. And it was introduced by this guy, Adam Dimitrick, circa 2018, I believe. And it's I don't know, some people argue that, storming modeling are almost the same thing. Don't want to get into that discussion. The difference is that from Adam's perspective, events are the source of truth. And he puts them like this. What you see is the blue line is the events. And if he puts them on a timeline, because you roughly can tell which event can happen before or after other event. So you build this timeline of events, like this can happen, then this, then this, then this, right? And then from there, you start to extract the system behavior. So if that happens, okay, so someone or something has to trigger it, right? So there has to be a component. Or this thing, for it to happen, needs this data. So there is this form on a web page or a UI or something that collects that data, and so on and so forth. And so essentially, your events become the central source of truth, and everything else, the whole design of the system, emerges from that. They did an interesting discovery when they were doing an exercise about using event modeling to model a zoo, and this is what Adam tweeted. As they were doing this, they discovered this event. Now, I honestly have no idea if that's a realistic event or not, but it serves the point to demonstrate how powerful the approach is. Like, I mean, picture your traditional design techniques. Would it ever cross your mind to actually account for an event like this? Probably not. But when you start doing it this way on the event modeling approach, all of a sudden you were like, hey, what if this happens? And then seconds later you may be like, I forget it. That's not going to happen. We're not going to deal it. But at least you consider it. You made an educated decision to ignore it if you did. Right? And then you can justify that. Yeah, we consider it and we ignore it for this reason. Or no, we did not. There is an action plan for this. And so now that's the way to model event-driven systems. So what is an event-driven system? Well, in a nutshell, it's simple. It's very, very simple. You have this piece of information that is a notification that something has happened, a decision has been made or whatever. We call that thing an event. And then you have two types of components. You have producers and you have consumers. And the producer produces event and the consumers are interested in events. Now, don't think about those as like Java code, like a class or an object or something. Think of those more of roles, right? That's the roles they play. Like there is no problem for a producer to be also a consumer, for example, right? So that's not a Java class. It's the behavioral role that those components have. And so the producers have some sort of data. They make some decisions. Once they make those decisions, they send this information to everyone else or to whoever is interested that something has happened, and that thing is what we call an event. Now, that thing needs to reach to the consumers. And in order to reach the consumers, we have this thing in the middle that we call the message router, because event essentially is a message. Right? So you need something that knows how to route messages. And then it routes that message to the consumer, and then the consumer decides what to do with that message. Right? Hands up, how many of you thought that? Yeah, no shame. Yeah, Kafka is a good solution. Yeah, that's what I thought. That's the usual case. Like every time I show this slide, people go, oh, Kafka. Yeah, well, we'll get into that. So that's essentially what event-driven is on a technical level, very simplified. But event-driven is also a few other things which I briefly going to mention here just so to not confuse things. So first of all, event-driven is a buzzword. It's a marketing term, and I don't mean that as a bad thing. It's totally okay to use event-driven in your marketing campaigns. Every time you want to do a product pitches, you do campaigns, whatever, right? It's totally fine. We do it. One of our products, Axon Framework, if you go to the GitHub page, it says building evolutionary event-driven, blah, blah, blah. Wow. You have to play the game. You want to tell the world what your software does. You want to be found by the people who are interested in this side of technology. So it's totally fine to use event-driven as a marketing term. The reason I'm mentioning this is you have to be very conscious when you are using it as a marketing term and when you are using it as a description of a technical solution, right? Because when you start mixing those up, right, you just use it in a technical conversation as a, well, we just do event-driven systems. That means nothing, right, unless you specify what exactly you mean by event-driven. Another thing event-driven is a false claim. And technically speaking, it's a false claim because it gives you the impression that the events are the driving factor, that everything that happens because of events. And that is an oversimplification of what actually happens, because events don't do anything, decisions do. Now, in your systems, there are decisions being made based on some data, like whether to do this or not to do that, whether to process or not to process, to turn it on and turn it off. Those decisions are the ones that are driving the system in some direction, right? Who makes that decision? Whether it's a software, whether it's a human, whether something, a rule engine or whatever, that's irrelevant. But it's the decisions that drives the system. Events are nothing more than notifications about those decisions. So they're post factum. After the decision has been made, they tell the world, we made that decision, right? So saying event-driven is an oversimplification of basically saying, well, the decisions were made to do this, and we're now just letting you know. And last but not least, event-driven is a polysemy. It's a lexical ambiguity, and because it doesn't tell you exactly what the system does. I mean, I showed you a diagram a few slides earlier, and I'm pretty sure if I ask every single one of you to implement that, you're going to come up with different ways of doing it. There's no universal a way of doing event-driven systems. And if you don't believe me, highly suggest you to go and see the talk or the article by Martin Fowler that's called The Many Meanings of Event-Driven Architecture. They actually did a study about what people mean by event-driven architecture. And they figure out people do a lot of different things, mean a lot of different things by just using that word. And I'm not going to go in details of everything that he says there, but I'm going to piggyback on two of the concepts he mentions because I think they're important to understand the stuff that is coming after that. First of those is event notification. Event notification, it's a very simple way of doing event-driven systems or doing communication in event-driven systems. And it essentially giving someone a short notice about something, right? As with all events, you don't expect a response because you just notify things, you just notify about things. So you don't expect someone to say, something in response, right? You just publish those events. Some other systems or, things are subscribing for those events, and that's it. Now, we can argue whether the order is significant or not significant. In some cases it is, most cases probably it's not. But essentially, it's kind of like LinkedIn sending you this. Hey, someone viewed your profile. Well, cool, LinkedIn. I wish I knew who and why and when and whatnot. But no, if you the only thing you know is that someone viewed your profile. So basically what you need to do, if you want to know more, is you have to go log into LinkedIn and check the details of like who, when, and whatnot. So that's essentially how event notification works. It just shoots a message to someone, says something happened, and if that someone needs to know more, they need to call you back and say, okay, got your notification, something happened, now tell me the details. And that works fine in a lot of systems, but it is an additional overhead, as you can imagine, because every time you need this callback to the system from which the event originates. Now, if you want to mitigate that, there is a different way of doing it, and it's called event-state transfer. Now, event-state transfer is essentially putting all the information in the pen drive and giving it to someone. I was like, it's all there, deal with it, like I did with my presentation. Yeah, and then you don't care anymore. Like supposedly, everything that the consumer wants is already provided to them, so they don't need to call you back. They can just operate on that piece of information that you provided. So you eliminate the direct communication back, which gives you resilience, which gives you reduced latency and all of other good things, but it also welcomes you to the land of eventual consistency. Now, you can forget about being strongly consistent because you have two systems that have copies of the data, their own copies of the data. So this is how it works. You just send that, and that other system makes a copy of the data on their side. Now, that doesn't have to be exact copy. Don't get me wrong. It doesn't have to be like I store it exactly as you send it. It can just do something and extract the data and reshape it and store it in whichever way it makes sense for the consumer system. But it makes a copy of the data, right, and stores it and operates on that copy. Which brings us to the very interesting question of the source of truth. So now you have two systems. Both of them have copy of the same data, and they claim two different things. Which one is right? Now, in a very simple systems, it may be relatively easy to determine that. In a complex systems, it becomes nearly impossible. And that is why a lot of tools exist for monitoring and auditing these types of things, because it all of a sudden becomes complex to know who of all the claims who is right and who is not. So if you do event notification, you don't have the problem. You always go back and ask. But if you do event carried state transfer, then for each pair, you have two different sources of truth. So that's the event notification, no problem here. But here, both sides claim things. So you have to be able to tell which one's right, which one's wrong. So this brings us to the idea of event streaming. So what's event streaming? Event streaming is essentially the idea like, if we already do this, why not put a stream of messages in that message router? So instead of just having a dump message router that just directly transfer the message to someone and forgets, let's make it hold a stream of all the events that pass by. And in this case, the consumers needs to know where is their position in the event stream. So basically they say, I know I've read these messages, so give me everything after that, right? So now, if you do this, you may be thinking that you know how. And then the source of truth question still remains though. So again, event notification is not a big deal. You don't have that problem. But how it changes with the source of truth when you do event carried state transfer? Well, it changes in a way that all the data you store on the consumer side essentially becomes a cache. You can do that for optimization purposes and whatnot. There's tons of reasons to do that. But the moment you have a misunderstanding, the two systems are claiming two different things, what you can do is you can safely remove your data storage on the consumer side and just reread the messages from the message stream and rebuild it, right? And so essentially that stream of messages in the center becomes your source of truth for the consumers. Everything they store locally, it's just for optimization purposes. The source of truth now has moved to the central place. How many of you taught this? How many of you do event sourcing? Not a lot. Okay. So you're going to find a lot of articles on the internet claiming that's how Kafka does event sourcing. And sorry to disappoint you, but strictly speaking, that's not event sourcing. Now, if that's not event sourcing, then let's talk about what it is. So event sourcing brings that idea even further, because in this slide, you still have two sources of truth. You have some data on the producer side and some data in that stream, and they still may be different. There still may be errors or failures or whatever that cause those two to disagree on things. So what if we get rid of one of those? That's essentially what event sourcing is about. And since we already have that central source of truth, how about getting rid of the data on the producer side? Ooh, scary thing, right? And that's where people get really confused. It's like, okay, well, wait a second. How can a component produce an event if they don't have any data? right? I mean, like, it makes no sense. You know, in order for the component to make a decision, it needs data, and only after it makes a decision, it can emit event, and then we can store it. So let's give you an example with abstract Java code. So imagine that producer is a Java class. So how that class makes a decision? Well, at some point in time, you will have to make an instance of that object, of that class, right? How do you do that? Typically, create a new object, right? And then what you do? You either do it yourself, or most likely you use some framework like Hibernate or something, or Spring, whatever, and you go to some database, and you read some records, or you go to a NoSQL and you read some documents or key values or whatever, and then you go back to this new object that you created, and you go set field, set field, set field, based on the data that you've read from some database, right? And then once you're done with this process, right, you instantiated an object that has information on basis of which it can make decisions. Then you make your decisions and send notifications and do whatever else. So how about we forget about that database and make that object read the events from that stream instead? So you do the same thing. You create a new instance of an object, but instead of reading the database, you go and say, give me all the events that I've produced in the past. And now, instead of saying name equals Milen, you say name equals something, and then name was changed to, and then name was changed again, and then name was deleted, and then name was added, and whatnot. And you just process all these events, and eventually it's going to bring you up to the state of the object as of today. And once you build it up, you can operate the same way you do when you read the data from a storage. And so if you can do this, you essentially get rid of the storage on the producer side. So now you truly have a single source of truth. Everything that has happened in the system is in one place, in the form of events, one after another. This happened, this happened, this happened. And this is what we call an event store. This is a place there that is specifically designed to store events. And now, a little fun. Kafka can do this with the help of some external tools, right? But that is far from efficient. And a lot of people fall for that because when you do this for a couple of million of events, it's not a big deal. I mean, like, for example, Oracle databases can safely handle tens, if not hundreds of millions of events, right? But at some point of time, it becomes to drastically decrease in performance. And if you really do, and you got to keep in mind, we're talking about storing events forever, right? So this is never going to get better. It's only going to get worse, right? So with time, any other solution that is not specifically designed for this type of operations will decrease in performance. So what an event store needs to be able to do in order to be efficient as an event store? Well, a few things. First of all, it has to be designed to be append only. And that's the significant difference between an event store and everything else, like databases, NoSQLs, and what else, and graph database and whatever. Those others, they are general purpose. Like, can you imagine a database which does not allow you to insert, update, and delete? I mean, it's hardly be a useful database, right? But for event stores, you don't have to implement those by design. And this gives you the ability to do tons of performance optimizations, because the only thing you need to be able to do is append an event at the end, period. That's it. Now, what it also needs to do is it needs to be able to give you a full sequential read. So basically say, give me all the events from 0 to whatever is the latest one. Now, if you are to implement this in a traditional database, for example, that basically mandates storing all the events in one table, or doing table joins, which is probably going to slow you even further down. All right, so doable, but not very convenient. But it also needs to be able to do replays. And replays are essentially the same thing from consumer perspective. So now as a consumer, say, give me all the events that I am subscribed to. So not all, but only those that I'm interested in, right? So now this, in traditional way, this could be, we need to put it in different tables, or you have different indexes or whatever. You know, it's doable, but it becomes more complicated. To make it even more complicated, from producer perspective, and I'm just using a DDD lingo here, the aggregate, but think of it as a producer. From a producer perspective, what you need to be able to do is to say, give me the events that I have produced in the past. I'm now rebuilding my state. I don't care what other components have said. I want to know what I've said in the past, right? So it's a different slicing and dicing the same data, right? So, and trying to figure out a proper and efficient way to store this in a generic storing solution, it's really hard, and it's going to be really painful down the road. Now, it's going to be painful down the road regardless, because this is an ever-growing storage, right? So no matter how many optimizations you do, there's going to be a point in time where there's going to be too many events to read them all, right? I mean, you know, a stupid example, if the name changes 1,000,000 times, you don't want to call your class 1,000,000 times and say, set it to A, set it to B, set it to A, set it to B, and so forth 1,000,000 times, right? It's just a waste of resources. So what you want to have instead is you want your event store to have the ability to do snapshots. And if you've done things with backups and whatnot, you're perfectly familiar with what a snapshot is. It basically says, give me the state as of now, right? And so the snapshot triggers are free to, usually, depends on your implementation, but normally you would want the event store to know, to give you the freedom to provide the definition of when to do snapshot, the rule. Well, you could provide a rule, say, make a snapshot every Tuesday, or every month, or on every 100 events, or whatever is your rule that makes sense business-wise. And then the event store does this for you. When the trigger, when the condition is triggered, and it takes a snapshot, it stores the state, and then appends events. And now, when you read, you don't have to go and read all these events. What you need to read is the latest snapshot and all the events after that. But should you ever need to read all the events, say for auditing purposes, or 5 years down the road, you just don't want to know what the current state is, but you want to know everything that has happened so you can feed it up to machine learning AI something and draw conclusions, you just can go and read all the events. It's the information of what happened is never gone. This is just optimization that allows you on a day-to-day basis to operate much better, much faster, and much more efficient. And last but not least, it would be great if your event store also gives you things like partitioning and archiving. And just quick example, if any of you have done any financial or like accounting systems or not, you're probably aware they close years, right? And some other industries, they close months and weeks and whatnot. And the reason for that is they basically say, okay, that's legacy data. We don't want it on a day-to-day operations. So we just close it and move it somewhere. And we keep up working with the current stuff, right? And that's the same thing here. At some point in time, you may want to say, I don't need that data on a day-to-day operation, so I'm just going to move it to a cheaper drive or something. But you still don't lose it. It's still there if you decide that you need it sometime in the future. So we have producers, we have consumers. We have this piece of information that notifies about changes, which we call event. We have event store. So we are event-driven, right? So can we agree that this is now the definition of event-driven? Well, far from that. First of all, because it's always going to be debatable. There's always going to be people that are claiming that, there are other ways to do things and whatnot. But most importantly, because we kind of miss two things here, which are very important and probably overlooked. And the things that I call passive-aggressive events. Ever heard that term before? Yeah, I guess I expected it. Okay, let me give you an example because it's really hard to explain it otherwise. Here is an event. Joe ordered to paint door 28 in red. Now, an event is a notification that something has happened. What has happened here? Joe ordered. Is that what is important in that event? Hardly, right? The important part is that someone wants the door to be painted. Now that someone most likely also wants to know if that request is going to be fulfilled or not. So that someone expects at least a confirmation, if not a response, right? If you ask someone to do something, most likely you would want them to tell you will they or will they not, right? So all of a sudden, it's not a notification, it's a request. It's a specific intent. It has a specific intent. You ask someone to do something, and this is what we typically call commands. So you don't notify that person, you ask them to, right? And don't notify that system, you ask it to do something, right? And in that case, you typically want that system to confirm or deny, right? I will or I will not, right? Let me give you another example. Joe asked, what is the color of the door 28? Now, you already know that's not an event, but what it is. It's a query. It's a request for information. You're sending a message to someone asking them to give you information back. Guess what's the most important part here? The most important part is what they give you back, because if they don't respond to you, the fact that you ask them for information makes absolutely no difference to anyone, right? So the most important part in this particular type of communication is the response. It's not a notifying about anything, it's asking for information. Now, how you would do this with a traditional event streaming solution? What, you're gonna create a topic where you send events that are tell me something, and then you get another topic where you get responses, and then you have correlation IDs. Okay, let's make it a little more harder. Not about door 28, but about all doors. Now, this is where people start saying, oh, event-driven is complicated. Yeah, it is if you start trying to pretend that everything is an event when it actually is not. But throughout this talk, I was deliberately talking about message router and not about event router. And the reason I was doing that is because all those are messages. And so are commands. So if we have a message router, we can design that message router to understand how to route commands as it routes events. And then from some endpoint, you can send the command saying, do this. The message router knows who can do this and routes that message to that component. And that component does this, notifies the world this was done, and so forth. Same thing for queries. We can have our message router understand how to route queries. It can route them to one or more recipients. It can even combine the results from multiple responses and return it as one result and whatnot. There's tons of things you can do here. But the important part is, those are different routing patterns. A routing pattern for events is different from those for commands, is different from those for queries, right? So you need a message router that understands how the communication works. Is that a command, is that a query, or is that an event? And that's the whole intelligence of the message router that you need. It doesn't have to inspect your messages, doesn't have to care what your payload is, doesn't have to be smart. All it needs to do is know that there are different routing patterns and which one to follow. And so if you reach this, and if you agree with, well, that this is a beneficial way to design systems, you will be on a much better place. And also, if you're familiar with CQRS, you would be like, yeah, you're talking about CQRS. And yes, to the point I am. So let me briefly explain to you what a CQRS is. CQRS was a technique that was introduced by this guy, Greg Young, and essentially when he did it back in 2010, I believe it was, he was basically saying, okay, design your stuff like you have an object that only has the right methods, like the state changing operations, and another object that only has queries, right? Just request information, right? Now things have evolved a lot since then. We're not talking about objects anymore. We're talking about models. And the reason we talk about models is it's hard to design, because basically this is what we do in software engineering. We have a real world, or an imaginary world in some cases, but the real world. And we want to do our systems to do something with it. So we create a model of it, right? And then we give that model to a system and to tell the system how to operate on the model, right? And so one of the fundamental problems with software design for many, many years is that we struggle to find that universal model. Like, how many of you have been there? Like, do we need that field? No, not for decision making, but someone may ask for it. Okay, let's put it in. That should be a separate object? No, let's put it in this object because when they ask for information, it's going to be more convenient. But it's going to be more troublesome when we change. Yeah, maybe we should introduce index. Endless conversations like this. And the reason is we were struggling to come up with one model that solves all the problems. Right? And that's next to impossible to do for complex systems. So if you follow the CQRS approach, you basically say my command model only contains the data that is important for decision making. So every time I change a state, I make a decision, I introduce something, whatever, that is the only data that I need in the command model. And I design it in a way that is optimized for decision making. Right, for those changes. And then on the query side, you can have as many models as you wish, because those are read-only. You don't have to worry about that anymore. You can store things in a database, and then the same things in an LDAP, and then the same things as files. Like think about invoices, for example. And nothing prevents you to pre-generate, store them as PDF, and then just serve them quickly, right? It's the same data. It's just different models that serves different purposes based on who is requesting them and what they need to do with that. But it doesn't, and you can change those at any time, and it doesn't affect any of the decision-making processes that you have in the system because those have their own model designed for optimized decision-making. And so the question is obvious then, like if we have this model here and this model is over there, how do we sync? And the answer is obvious. Events. Every time we make a decision, we send an event. We inform the world we made a change. And then your read models can update their database, their LDAP server, their NoSQL, their whatever, right? And we already have a place to do this, right? If we design event-driven systems this way, you already kind of done this. Like you have the whole groundwork laid out for commands, queries, and events. So all of a sudden, these things that appear very complex become not so complex. And one thing that we at AxonIQ realize is that we can help people do this. So this is every time you talk to someone at AxonIQ and they say event-driven systems, this is what they mean, right? And we design solutions to help other people, deal with those problems even better. So the two in the middle is essentially one is a on-premises Axon Server. Axon Cloud is the in the cloud version of Axon Server. That is an event store and a message router in one. So think of it like Kafka and a database together, or whatever is your storage solution. So all these things that we discussed earlier about efficient message routing, understanding the 3 different types of messages, and event storing, like all the benefits of having an event store, all that is an Axon Server. And so you can just snap it in the middle, and then it's going to take care of all of that stuff that we were discussing earlier. It's not strictly open source, but it's free to use. The only difference between our license and the full open source license is that you cannot clone it and make a commercial version of it. But other than that, it's pretty much open source. Now, the other thing that typically I find amusing is every time we have these diagrams and we draw these arrows. And it's like, oh, this system's going to talk to that system, arrow, right? And I always joke around that the hardest part in such diagrams is implementing an arrow. Like, how do it's easy on PowerPoint, you just draw something. But when you start implementing and you start talking about protocols and error handling and tons of other things, right? So all of a sudden, that tiny arrow on the diagram becomes an implementation problem. And to solve that problem, there is a fully, completely, 100% open source Axon framework, which is a Java framework, or should I say JVM languages framework, because surprisingly most people are these days using it with Kotlin and other languages. But any language on the JVM would do, and it helps you exactly to do those things. So that's tons of different things which I'm not going to go into, but fundamentally, it does two things for you. It gives you buses, like event bus, command bus, and query bus. So your components can send events, queries, and commands, and then the system knows how to route them. And it also, on the consumer side, it gives you a set of convenient annotations. So you can annotate your classes and objects and say, okay, I'm an event handler. I know how to handle this event. I'm a command handler. I know how to do this command. And then, you wire it all together, and then the system behaves exactly the same way, whether those components are within the same JVM or in two different servers on to the other end of the world. Right? The communication pattern between those never changes. So here is some information brief about what I already mentioned. I'm going to mention a few other things in here. AxonIQ Academy, if you want to learn more, this is what we run. We have some free courses there about the concepts. If you do the free courses and you want to learn more, ping me. I'll give you access to the other courses for free. AxonIQ Discuss is our platform where you can talk to our community, and not only about the project that we have, but in general, we have a lot of people coming there and it's like, I want to design a system this way, but I'm not sure if this is a good idea. And we have people from the community who already have done this, and they can provide you valuable advice or suggestions or warn you about things. AxonIQ Initializers is, if you are a Spring Boot fans, which I assume most of you are, then if you want to do something like the Start Spring that generates a project for you in Maven or Gradle, well, that's the place to go. And finally, my colleague Sartori is running a Exploring Axon podcast. If you are into podcasts, she talks to a lot of interesting people there, including the folks I mentioned earlier in the presentation. So if you are into podcasts, please check that out. I hope you learned something new today, and I hope it was useful for you guys. Thank you so much for having me today and being patient to listen to all the things I have to say. That said, we think not have time for questions, but I will be around for the entire conference. So please, you're more than welcome to find me and have a conversation about any of those topics. Thank you very much.